Okay, we're going to talk about partial fractions, and we're going to start by just adding two rational expressions. So let's say we have simple expression 1 over s plus 1 plus 3 over s plus 2. Well, we can take the 1 over s plus 1 and multiply it by s plus 2 over s plus 2. And we have then denominator s plus 1 times s plus 2. Now we want a common denominator, and it's clear our common denominator is going to be this times this. So we come over here and we do 3 over s plus 2 and multiply that by s plus 1 over s plus 1. And we get s plus 2 over s plus 1 times s plus 2 plus 3s plus 3, multiplying 3 through the s plus 1 over s plus 1 times s plus 2. Okay? And then we can just say, well, that's we can add the numerators because we have a common denominator. So that gives us 4s plus 5 over s plus 1 times s plus 2. And we can even then say, okay, that's 4s plus 5 over s squared plus 3s plus 2. Okay? Now, it's easy if we have a sum of two rational expressions like this to do this. Yeah, the algebra might be painful, might be error prone, but the idea is easy. We just use a common denominator, put everything together, multiply everything out, right? What if we had this and wanted to put it in this form? Okay, so I'm going to say not difficult to put this being this, into this form. How would we go about putting 4s plus 5 over s squared plus 3s plus 2 into the form one over s plus 1 plus 3 over s plus 2? Of course, if we didn't already know. Okay? Well, here's our technique. Well, first I say first thing we have to do is factor. Okay? Well, easy enough to factor. Denominator's quadratic. Okay? We can factor it, and if we can't find rational factors, we can set this equal to 0 and use the quadratic formula and find the factors. Probably not going to make you do that. Actually, maybe I will, because you're going to have a take-home final. Probably not. Okay, you get 4s plus 5 over s plus 1 times s plus 2. Okay? Now, I'm saying that 4s plus 5 over s plus 1 times s plus 2 has to equal some number over s plus 1 plus another number over s plus 2. Because I know that if I have this form, I can put it over a common denominator. I'm going to have an a times s plus 2 and a b times s plus 1. And my denominator is going to be s plus 1 times s plus 2. Okay? So I can say since the common denominator here is s plus 1 times s plus 2. So already this is in this form, but we've got to figure out what a and b have to be. So we're going to get two simultaneous equations, which then be quite easy to solve. Okay? And when we solve those equations, we're going to find that a has to be 1 and b has to be 3. Okay, so, well, what we do is we say that this will then equal first of all, putting this over common denominator, we just multiply by s plus 2 over s plus 2. And then here we multiply numerator and denominator by s plus 1. And this equals, well, we have a common denominator, so we can just multiply out the numerators. And we can add the numerators. So this numerator is as plus 2a, there it is. This numerator is bs plus b, there it is. And now I can write this as a plus b times s well, take the a and the b, the as and the bs, and factor out the s, and then we have the 2a and the b. Okay, now at this stage I need more board room and I don't have it. So I'm going to use this board. Actually, I don't have to do that. So bear with me for a second. More simple algebra. But in a slightly expanded context that you don't want to know about. You might find it interesting, but you have other things to do in your life. And spend 2 more years taking math courses so you can understand that one.
But we're not going to have.
I don't doubt that you could do it though. I'm not recommending that you do it unless you find that you just can't be happy without doing it. And from your reaction, I think you're going to telling me they're going to be happier if you don't do it. So, and that's the case for most people. You're not interested in becoming an engineer. Anyhow, but you could. Okay. So anyhow, where we are is now we know that this expression is going to be equal to whatever it was, what we got over there, which was 4s plus 5, yeah. Okay? Because this is what we started with. Okay? Now we've just taken this equality here, and all we've done is rewritten it. We've rewritten this expression, it's equal to this, and it's still equal to the original expression. Okay, so the denominators are the same, so the numerators have to be the same. And this has to be true for all possible values of s. Now, if it's true for all possible values of s, then the number in front of s has to be the same on both sides, because if it wasn't, changing s would change everything. Okay? Because this number then has to equal this number. Okay? Since s can change, the coefficient of s has to be the same on both sides. Okay? Because 2a plus b has to equal 5 no matter what. So we have a plus b has to equal 5. The coefficient of s has to be the same on both sides. And 2a plus b has to equal 5. Now I said 5 because I'm incapable of clerical operations, but it should be 4. So obviously the coefficient of s is 4, not 5. Okay? So I do differential equations fine, but the clerical part, no. You know, much more than that, but clerical getting away from me. Okay, so anyhow, a plus b is 4, 2a plus b is 5. Well, we can easily solve this equation. Okay? Like we just do equation 1 minus equation 2 gives us negative a equals negative 1. So a equals 1. Then equation 1 tells us that 1 plus b has to equal 4, so that b equals 3. Okay? And our conclusion is 4s plus 5 over s plus 1 times s plus 2 equals, well, I said it's going to be a over s plus 1 plus b over s plus 2, which now that we know a and b has to equal 1 over s plus 1 plus 3 over s plus 2. And of course, this expression is what we started with. So from this expression, we factored the denominator to get this. Then we said that, well, anything over this times this has to be something over this plus something over this. We did the algebra to put that over common denominator, and we got this, which gave us this equation, so that a plus b had the coefficient of s had to equal the coefficient of s, a plus b had to equal 4, and the part that didn't have an s on it had to equal 5. Easy to solve the equation, very easy in this case. And then we just write out our original assumption, and we have recovered our original. Okay? So, that demonstrates, at least in this case, the method of partial fractions. Now there are other cases, so we'll look at those.